Here are the solutions for Lesson 8-1, Day 2. Now, these are textbook problems, but to make your time a little more efficient, I've created a handout for the textbook problems. The first skill is state whether an ordered pair is a solution of a given equation that has two variables. In number 2, we have an equation that has the variable m and the variable n. And then there's an ordered pair, 6, 7, to check if that solves that equation. The 6 is the value of m, and the 7 will be the value of n. Ordered pairs are always in alphabetical order. To decide if it's a solution, the method is to substitute the values from the ordered pair into the equation. So we have 4 times, and then in place of m, put 6, and then minus 5 times, and in place of n, put 7. Now what we want to know is, does using those numbers solve the equation? Does that equal to 9, which is the number on the right side of the original equation? 4 times 6 is 24. Negative 5 times 7 is negative 35. And 24 subtract 35 is not 9. So this is no. Now, B has another ordered pair to try. Maybe 6, 3 is a solution. So in place of the letter M, fill in 6. And in place of the letter N, fill in 3. And again, we're wondering, does that equal 9? So 4 times 6 is 24. And 5 times 3 is 15. And 24 subtract 15 is 9. So this is yes. 6, 3 is a solution to the equation. So this is how you do this skill, where you have an equation with two variables and you're given an ordered pair and asked to check whether it works or not. So in number 6, this is going to be the value of x, and this one will be the value of y. So 5 times 7 minus 4 times 6. And we're wondering, is that 9? 5 times 7 is 35. 4 times 6 is 24. And 35 subtract 24 is 11, not 9. So this is no. Now, what about the ordered pair negative 3, negative 6? So in place of x, substitute negative 3. In place of y, substitute negative 6, and we're wondering, does that equal 9? 5 times negative 3 is negative 15. Negative 4 times negative 6 is positive 24. And negative 15 plus 24 is 9. So this is yes. Now the next skill is to find ordered pairs yourself. Solve each equation if this is the domain for x. X is an element of this list of numbers. So it's these 5 numbers that we're going to use as input values for the variable x. And for each of these 5 inputs, we'll calculate the answer for y. The method is to solve the original equation for y. So in problem 14, to get the letter y alone, you have to subtract the 5x from both sides. That will create y is equal to 7 minus 5x. This becomes the formula that you use to get the output values for y when you use different numbers in place of x. So the first number we're supposed to input for x is negative 2. So over on this side of the screen, we'll use our formula, and in place of x, put in negative 2. And figure out what this equals. This is 7 plus 10, which is 17. So in the chart, this value is 17. Now for the next row of the chart, use the same formula, but this time fill in negative 1. This becomes 7 plus 5, which is 12. For the next row of the chart, fill in 0. This becomes 7 minus 0, which is 7. Now, as the value of x increases by 1 unit from row to row, do you yet see a pattern happening for the y values? Is there a consistent change occurring from row to row? As soon as you figure out that change, then you can figure out the other output values without having to work out the work over here on the side. It looks like the y is decreasing by 5. 17 minus 5 makes 12. 12 minus 5 makes 7. 7 minus 5 makes 2. 2 minus 5 makes negative 3. Now, if you're unsure how to do that or you don't see a pattern, you can always continue doing the work over here on the side to get your output value. Now, question 16. First step, solve for y. So we need to subtract the x term from both sides. That makes 5y is equal to 10 subtract 2x. Now divide by 5 in all terms. This makes y equals 2 take away 2/5 x. Here's our formula that we're going to use to generate answers for y based upon different numbers that we input where the x is. So using that formula, we have 2 minus 2/5 times negative 2. What does this make? This is 2 plus 4/5, which is the mixed number 2 and 4/5. If you're doing this on a calculator, it maybe would give you a decimal. Maybe it says 2.8. That's the same answer. Now for the next row, 2 minus 2/5, and in place of x, use negative 1. What does this make? This is 2 plus 2/5, which is the mixed number 2 and 2/5. Now, each time x increases by 1 going row to row, what do you observe happening to the y values? Let's do one more row and see if what you're thinking is correct. Substitute in 0. This becomes 2 subtract 0, which is 2. It looks like from this row to this row, it's decreasing by 2/5. The same thing here. It decreased by 2/5. So what would the next row be? It's going to be 1 and 3/5. And then if you subtract 2/5 from that, you're going to get 1 and 1/5. Again, you can always work out the work over here on the side if you'd rather get the answer that way. Now number 18, solve for y. So first step, subtract x to get the x term to move to the other side. We get 9 minus x. Then divide by 3 in all spots. This is y equals 3 minus x over 3. Or instead of x over 3, you could write 1/3 x. That's the same thing as saying x over 3. Either is fine. Now to get our chart filled in. 3 minus 1/3 times, and in place of x, put in negative 2. This is 3 plus 2/3. And that's the mixed number 3 and 2/3. Now for the next row. 3 minus 1/3. What are you inputting for x? Negative 1. This is 3 plus 1/3, which is 3 and 1/3. Now, what's happening from here to here? Do you see how it's changed? It looks like it's decreasing by 1/3. So the next row will be 3. And then if you decrease by 1/3, you'll get 2 and 2/3. And then if you decrease by another 1/3, you'll be 2 1/3. Now, number 20, solve for y. You need to subtract the 3x to get it to move to the other side. And you'll have y is equal to 7 subtract 3x. Or you could write it as y is equal to negative 3x plus 7. These are the same answer. Okay, now over here on the side, let's use our formula. 7 minus 3 times in input negative 2 for the x. This is 7 plus 6, which makes 13. Now the next row, 7 minus 3 times x. What are we using for x in this row? Negative 1. This is 7 plus 3, which is 10. Okay, from row to row, every time that x increases by 1 unit, how is this changing? It's decreasing by 3. And so 10 minus 3 is 7, 7 minus 3 is 4, and 4 minus 3 is 1. Now, number 22, solve the equation for y. We have to divide by the x on both sides. So we get y is equal to 12 over x. So over here, to get the answer for y, it's 12 over x. But what's x? Negative 2 in the first row, and that makes negative 6. Next, we have 12 over the value of x, which is negative 1, and that makes negative 12. Next, we have 12 over 0. Division by 0 is undefined, so there is no number that you get for y. So in here you want to write undefined, or you might write error. If you do this on a calculator, it's going to say error, right? X is a restricted value. There is no ordered pair that goes 0, comma, and then some number for y. Okay, next we're going to have 12 divided by 1. That makes 12. And then 12 divided by 2. And that makes 6. Okay, number 24. Solve for y. Divide by the coefficient on both sides. So we get y is equal to 30 divided by 5 is 6. And there's an x in the bottom as well. That's our formula. So what is 6 divided by negative 2 make? That's negative 3. What is 6 divided by negative 1? That's negative 6. How about 6 divided by 0? 0 is a restricted value. This is undefined. Okay, how about 6 divided by 1? That makes 6. And then 6 divided by 2, and that makes 3. You have been manually calculating each output value, probably using the TI-30 calculator. But an even faster way is to use the technology that's available in a graphing calculator. So on your Chromebook, in classwork and under calculators, there's another calculator provided, which is the TI-84 Plus. I'd like you to follow these instructions on that calculator. First, push second and table set. The blue button is the second button, and table set is this second gray button at the top. And make the starting value of our table negative 2 by typing the negative button and then the 2. Have the table change by ones. That is, from row to row, have it increase by 1. And have it automatically fill in independent variables and have the calculator automatically figure out the corresponding dependent variables. Next, click Quit by pushing the blue button and then the Quit button, which is the same as the button called Mode. This takes us back to the home screen. So what we've done so far, done the table start at -2, and we have our delta table changing by 1 from row to row, and we have the word auto and the word auto for those other choices. Now you're going to push the y equals button on the calculator. If there's anything already entered in your calculator, you'll push clear. And next, for where it says y1, you're going to input the right side of your transformed equation. Now, by transformed equation, I'm referring to when you solve the equation for y, which was the first step that we've been doing all along. So in problem 26, to solve for y, we first have to subtract 6 from both sides. That makes xy is equal to 6. Next, divide by x on both sides. And our transformed equation is y equals 6 over x. So I'm going to bring up the calculator again and follow those steps. Push y equals, which is the left gray button. I don't have anything filled in for any of these rows. If I did, I would push clear to clear it. Now I'm going to type the right side of the transformed equation. Do you remember what that was? 6 over x, or 6 divided by x. So 6 divide x. The button that does x is this button here that also says x, t, theta, and n. It's next to the green button. If you push it, it types an x on the screen. So now we've done all of these directions. The last thing to do is to push the second key and then the table button. Let me bring up my calculator. Second, table. Table is the 5th gray button that also says graph. And here is the table. Notice that the first row of the table is -2 because we told the table to start with -2. And notice that the x values are changing by 1. -1, 0, 1, 2, 3, 4, and so on. That's because our table settings have delta table set to be 1. We want the row to change by 1 from row to row. Notice that the x column is automatically filled in because we had picked auto. And notice that the y column has been automatically filled in because we picked auto. What we do is simply copy in the numbers from the calculator into the table on our handout. I see the numbers are -3, -6, error, 6, and 3. -6, -3, error. Earlier we wrote undefined for that because you're not allowed to use 0. Then 6, and then 3. Number 28. Let's use the TI-84 calculator to automatically get the values for y. So the first thing you do is solve the equation for y. Subtract 8 from both sides. 4xy is equal to 28. To get y alone, divide both sides by 4x. Y is equal to 28 divided by 4 makes 7, and the letter x is in the bottom. So we have y equals 7 over x. 7 over x is what we want to type in on our calculator. What button did we push to type in the equation? We pushed the y equals button, the first gray button. Let's clear out our old one by pushing clear. And type in our new expression, 7 divided by x. To make the letter x, it's the button next to the green button. It actually says x, t, theta, and n, but if we push it in this current mode, it's going to put an x on the screen. Now, what did we do to show the table? We pushed the second key and then table, which is the 5th gray button. And it shows the table with the numbers that we need. So -3.5, or as a mixed number, -3.5, then -7, then it says error, and then 7, and then 3.5. So negative 3.5, then it was negative 7, then it said error because 0 is restricted, then it said 7, and then it said 3.5. Number 30, solve for y. The x plus 6 is being multiplied in front of the y. The x plus 6 is the coefficient of the y. So to get y alone, we divide both sides by x plus 6. The x plus 6's cancel away, and now the letter y is alone. So 7 over x plus 6. And this expression is what you type in on the calculator. So I'm going to bring up the calculator again, push the y equals button, clear that one, and type in the new expression. 7 divided by x plus 6. Notice that I had to put the x plus 6 in parentheses so the calculator knew that I was dividing by the binomial x plus 6. Now the other thing you could type in is you could type it in so it looks like what it looked like on the paper, which was a fraction. On the TI-84 calculator, to make a fraction, you push the green key and then the first of the gray buttons. It brings up 4 choices, and we want choice 1, N over D, which is the same button on the TI-30 that we use for calculator, N over D, numerator over denominator. So choice 1. Now I can put the 7 on the top, and I can put x plus 6 in the bottom. So maybe you're more comfortable typing it in like this because this looks more like what was on the paper. They're the same thing, so it doesn't matter which you type in. Now to make the table, second table. And we see our values filled in. So that first way that I typed in, the answers on the calculator are given to me in decimals. That second way that I typed it in, because I had used the fraction button to type it in, the answers given to me are fractions. But the numbers in blue and the numbers in red are really equal to each other. So now we need to transfer these numbers to our paper. In decimal form, this was 1.75. The next answer was 1.4. The next answer was 1.16 repeating. It actually said like 1.16666. It was repeating. The next one was just 1. And the next one was 0.875. Now number 32. Solve for y. The 3 minus x, that binomial, is being times to the letter y. So to remove it, you use division on both sides. That will get the letter y alone. And we end up getting 6 over 3 minus x. And that's what you type in the calculator. So I'm going to go back to the calculator, push y equals, clear away these two, and type in that new expression. It was 6 over 3 minus x. So 6 divided by, parentheses, 3 subtract x. Close the parentheses. Or type it in using the fraction style. Okay, again, here's how you do this on this calculator. To make a fraction, you have to bring up the n over d option. To do that, you push alpha, and then the first gray button, a little menu pops up, and choice 1 is your numerator and denominator feature. And then put 3 subtract x in the bottom. These are equivalent things. You don't have to type them both in. I'm just showing you what they look like. Now make the table. To make the table, you want to push the button called table, but see how it's written in blue? So you push the second key, and then table. Here are the answers in blue as decimals and the same answers in red as fractions. Using the decimal version, it was 1.2, then 1.5, then 2, then 3, and then 6. For those last few problems, we used the TI-84 Plus calculator to calculate outputs. But that only works if you transform the equation to get the variable y alone. Instead of the TI-84 calculator, we could use the Desmos graphing calculator, which is also available to you in Google Classroom. This allows you to input a non-transformed equation. So on the Desmos calculator, let's follow through these steps. We'll input the equation as it's given without first solving it for y. Then, if needed, we'll move or zoom the graph until we can easily find the x values that we're using. And then I'll show you how you use the cursor to find the ordered pairs that will fill in our XY table. So we need to bring up the Desmos calculator in Google Classroom. Under calculators, this time pick Desmos. And the Desmos calculator looks like this. Now over here on the left in this first box, this is where we click in there. And this is where you'll type in the equation. But what's nice about this calculator is you don't have to first solve the equation for y. We can just type it in exactly as it is in the book. So for number 34, we'll type in this. xy equals 6 minus x. On your Chromebook, type that in. xy equals 6 subtract x. And my graph is red. I don't know if yours is going to be red or not. The color of it doesn't matter. What we're going to do is find the ordered pairs on the graph that use the different x values from our table. If needed, you might click your touchpad and drag your finger to center the graph. The other thing you could do is you can zoom. Over on the side of your Desmos calculator, there's a little plus and minus sign, which are your zoom buttons. So you can zoom in, or with the minus sign, you can zoom out. You just need to be able to find where on the graph the x-coordinate is -2. So along your x-axis, go over to -2, then go straight down with the cursor to where the red graph is located, and click at that spot. You notice it says -2, -4. So when x is -2, the y value is -4. And we can record that in our chart. -4. Now what is the value of y when x is -1? Well, -1 is located here, halfway between 0 and -2. My red graph is below this spot, so I would need to go downwards until I reach my red graph. But I notice that's right at the edge of my window as I record my video. So I can grab and move my graph up so that I'm able to find the spot on the graph. I think right here, when I click that spot, I get -1, -7. So in the chart, -7. Now what about when x is 0? Here's where x is 0. As I look downwards, I see that the red curve gets closer and closer to where x is 0, but never touches it. And if I look at the other section of the graph, the same thing. The red colored graph is getting close to where x is 0, but it's never going to actually touch it. Not even if I drag way, way up here. It gets close to the y-axis, but never actually touches it. What that means is there is no point on the graph that has an x value of 0. 0 must have been restricted. So we record either the word error or undefined. There is no ordered pair on the graph that has an x-coordinate of 0. Now what about when x is 1? The origin at 0. Here's where x is 1. Here's where x is 1, halfway between 0 and 2. Now go straight up till you get to the graph and click at that location, and it is 1, 5. Now what about when x is 2? On the x-axis, here is 2. Go up until you get to the red graph, and once you're there, click at that location, and it says 2, 2. So we can fill in that y is 2 when x is 2. All right, number 36 is the last problem. Let's do this one with the Desmos calculator again. So the Desmos calculator allows you to type in that expression without first transforming it. So we want to do xy plus x equals 12. xy plus x equals 12. Now with my graph as it's showing on the screen right now, I can't see the dot on the graph when x is -2. It's off the bottom of my viewing window. So I'll click and move the graph so that the spot that I need to see is actually on screen to me. Where x is -2 is this spot here on the x-axis. And then I go down till I get to my red graph. And right here is the spot of interest. It says -2, -7. Now what about when x is -1? In the current window, -1 is halfway between 0 and -2. It's this spot right here. But the red graph is off the bottom of my screen. So I can drag up, but if I do that, now I'm losing where my x-axis is. That may or may not be a problem. You maybe still remember which of the little grid lines was -1. The other thing you can do is you can use the zoom capabilities, right? And zoom out and move the graph if you need to. You just need to be able to get the spot that you're looking for on your screen. So here's where -1 is. And then I go downwards till I get to my red graph and then click at that location. It looks like it's -1, -13. So when x is -1, y is -13. What about when x is 0? Well, as I look down, the red line is getting closer and closer to the y-axis, but never touches it. And even if I was to look further up here, the red line, while it is getting closer and closer and closer and closer to the y-axis, is never going to touch it. And so this tells me that x must have been a restricted value. There's no ordered pair on the graph that has an x-coordinate of 0. Write the word error or write undefined. Now what about when x is 1 and when x is 2? Move the graph until you can see the point of interest. On the x-axis, here is 0. 1 unit over is where 1 is. And then go straight up and click the spot that you need. It looks like it is 1, 11. What about when x is 2? So 2 is right here on the x-axis, and go up and click that spot, or simply just look over on the side and notice it's at 5. So when x is 2, y is 5. So 11 and 5 are my two numbers. So in this lesson, we figured out answers for y by using different input values for x. We started by doing it manually on the TI-30 calculator. Then we used the TI-84 calculator. And then we even used the Desmos calculator. Which way did you like the best?